Hello everyone and welcome to 7th grade Math Module 3, Expressions and Equations. In this video we're looking at lessons 3.1 and 3.2, Generating Equivalent Expressions. Our learning goal is to make sure we can write equivalent expressions by combining like terms. This will help us to master Standard 7 EEA1, apply properties of operations as strategies to add, subtract, factor, and expand linear expressions with rational coefficients, and 7 EEA2, understand that rewriting an expression in different forms in a problem context can shed light on the problem and how the quantities are related. Before we get started, we need to review some algebra terms that you may already know. An expression is a combination of constants, which are regular numbers, variables, which are often letters that represent a variety of numbers, and/or operation symbols without an equal sign. So for example, 3x plus 2x plus 4 plus 7 could all combine together to make an expression. An expression might not have all of the things listed below. It could just be variables, or it could be regular numbers, even without operation symbols. The things that we find inside of our expression are called terms. Those are the quantities that are being added or subtracted in an expression. So 3x would be considered one term even though the numbers are being multiplied together, whereas 4 by itself is still also a term. Like terms are terms that are going to have the same variable, including any exponents that go with the variable. So 3x and 2x are like terms because they both have the variable of x to the first power. We could also consider 4 and 7 as constants to be like terms because they do not have any variable with them. We're going to try combining like terms to rewrite 5x plus 3x as a single term, and then with 5x minus 3x. So when I have 5x plus 3x, to combine these like terms, which are alike because they share a variable, all I need to do is add my coefficient, the number that is being multiplied by my variable. The reason this works is because I can think of 5 times x as x being added 5 times, and I can think of 3 times x as x being added 3 times. So if I write that out as addition, I see that I have 8 x's altogether, and 5 plus 3 equals 8. So 5x plus 3x equals 8x. If I try to do the same thing with 5x minus 3x, I can still think of each of those terms as being x added that many times, but instead of adding the 3 x's to the 5x, I'm going to take away 3 of the x's, which leaves me with 2x. And the coefficient subtracted, 5 minus 3, get us that coefficient of our simplified expression of 2x. We can try the same thing with 2x plus 1 plus 5x. You can pause the video now to try to combine the terms that are alike and share a variable. How did it go? When you go to combine these, you should see that because you have 2 x's and then 5 x's being added together, you have 7 x's. Then, because the 1 does not have the same variable, the plus 1 is going to remain separate from the 7x. So our final answer has more than one term. This is okay when you are combining like terms. You should only see each type of term once in your solution, but you may have more than one term in your expression. When we try to simplify our expression into a simpler expression when we have multiplication, it is very easy for us to just rewrite it by multiplying any coefficients of our variables. So for example, if I have 3 times 2x, that is the same as saying I have 2x plus itself 3 times. Using what we already know about combining like terms, we would add our coefficients to see that there are 6 x's total here. The shortcut for solving this is that we can just multiply the 3 and the 2 together since both are being multiplied with x, and we would get our solution of 6x. You can pause the video here to try to simplify the other expressions using multiplication. How did it go? You could have written out all of your expressions showing how many times your numbers showed up in that term. So for example, since there was 5 times 4y, you could have written out 4y being added to itself 5 times. Or you could have just done 4 times 5. Whichever strategy you chose should have gotten you 20x. With 4 times 2 times z, even though the terms are separated by those dots, they are still one term. And when we do 4 times 2, we get 8z. Finally, for the last one, we have 3 times 2x and 4y times 5. They are separated by addition, and they have different variables. Because they are separated by addition, we only want to multiply the coefficients that go with the same variable. So we would multiply the 3 and the 2 and keep that 6 as the coefficient for x, and then 4 times 5 and keep the coefficient of 20 with y. So our final expression is 6x plus 20y. Again, even though there is more than one term, this is still the simplest expression because our like terms are separated. We may also find that some of our problems get a little more advanced when we start combining larger expressions. So for example, if we are subtracting the sum of 40 and 9 minus the sum of 30 and 2, normally you guys would just follow PEMDAS and you would add what was inside of your parentheses and then subtract to get 17. With algebra, if we have variables in there, combining our terms might not be possible if the terms are not alike. So we will need to line up our terms that are alike and subtract them that way. So for example, with this problem, I could have done 40 minus 30 and then 9 minus 2 and seen that I was left with 10 plus 7, which is 17. That seems a little confusing compared to how we're used to doing it, which is a little more straightforward. So let's see it with a problem that's algebraic where we don't have that option. So if we are subtracting 3x plus 5y minus 4 minus the sum of 4x plus 11, it helps a lot to organize this by arranging the problem vertically, making sure that our like terms are on top of each other. So I put 3x and 4x on top of each other, and I put my constants of 4 and 11 on top of each other. Because there is no term with a y in the second parentheses, I had no term to pair with my 5y. So now what I need to do is subtract away all of the numbers on the bottom from the numbers on the top. So I would do 3x minus 4x, and I would get negative x. Then I would do 5y minus nothing and end up with 5y. And then negative 4 minus positive 11 to get negative 15. So my expression, when I'm finished subtracting, should be negative x plus 5y minus 15. It is okay that I have 3 terms in my solution because in my original expressions, I had 3 different types of terms, 2 with an x, 1 with a y, and then 2 constants with no variable. You can pause the video to try to combine the terms below, 5a plus 3b minus 6c, plus 2a minus 4b plus 13c. How did it go? Luckily for us, these equations already have our like terms written in the correct order. So when you go to write your equations vertically, they should line up nicely. Because this is addition, all you need to do is then add your coefficients for these variables. So 5a plus 2a is 7a. 3b minus 4b leaves us with 1 negative b, so just negative b minus b. And then negative 6c plus 13c gets us 7c. So our final expression is 7a minus b plus 7c. What does this make you wonder about combining like terms? Write your questions down so you don't forget them. Then you can try to find answers online or ask a classmate or teacher. Thanks for watching, and when you're trying this on your own, remember, if you learned from your failures, then you succeeded.